So now we want to talk about medians, and we want to talk about how they work together to help us continue find parts of a triangle. So our first definition is the median concurrency theorem. The median concurrency theorem states that the point of concurrency for a triangle's medians is located 2/3 the distance of the whole median, starting, this part's important, starting from the vertex. And so again, concurrency means where lines are intersecting each other at a point. So if we draw out the medians for this triangle, B to E, C to F, A to D, and we know that they're the medians because they're coming from a vertex, they're hitting the opposite side, and doing so creating congruent segments on either side of it. That makes it a median. And they're all going through this point G. So they are concurrent at the point of concurrency, that is G. So then what this is saying is that the point of concurrency for a triangle's medians is located 2/3 the distance of the whole median starting at the vertical side. So this vertex side. So this AG segment right here, this segment by definition is 2/3 the length of the whole AD side. So A to G is 2/3 of AD. It is the AD length times 2/3. Which means, if that's only 2/3 of it, we're missing a third, this means that the GD side of this line is 1/3 of the whole length. Because if you put those together, 2/3 and 1/3 makes 3/3. It makes the whole length together. So AG, take the whole length of AD and you multiply it by 2/3 to get the length. DG, you take the whole length of AD and you multiply it by 1/3 to get AD. This also means, to take it one step further, this 2/3, if AG is 2/3 of AD, but all you had was this short pink segment, to get from 1/3 to 2/3, if you had this DG segment, you would just multiply by 2. Because 1/3 times 2 is 2/3. So to get from the short segment to the longer segment, you would just multiply whatever you have by 2. Or to get from this short segment to the whole length, you would multiply what you have by 3. And we'll see those worked out in a few problems. Now the other thing we want to look at is G itself. So if we were on a coordinate plane, and we knew the coordinates of A, it was x1, y1, the coordinates of C, it was x3, y3, and the coordinate of B, which is x2, y2. If we knew these coordinates, then we could say that the centroid, which is the point of concurrency of the medians, the center of the triangle, the centroid is located at taking our x values, adding them together and dividing by 3, and taking our y values and adding them together and dividing by 3. This is going to give us a point. This is essentially the same formula that the midpoint formula is, just one more number is added onto it. Instead of x1 plus x2, it's x1 plus x2 plus x3. So this is going to give us a coordinate. But you take all of your x values, you add them together, because there's 3 of them, you divide by 3. Take all of your y values, add them together, because there's 3 of them, you divide by 3. And that's going to tell you the centroid. It's going to tell you the dead center, the point of concurrency of your medians. So for our first question, we want to know what is the length of JN, this here, what's that whole length? And then we want to know what is the length of QN. And then it says if J, L, and K are at those coordinates, where is the centroid? So let's start with the lengths. So Jn, if we have this length right here, JQ, this segment here is equal to, and because it's going from the vertex to the center, JQ is equal to 2/3 of the JN length. Now, if we know what JQ is, it's 18. 18 is equal to 2/3 Jn. And from here we can solve. So if we are dividing by 3 like this fraction is telling us, we can start by multiplying this whole equation by 3. And so 3 times 18 gives me 54. 3 times 2/3 gives me 2 Jn. And then from here, to get n by itself, or my bad, to get Jn, oh, there was a J there. To get Jn by itself, put a parenthesis around it so we can read our handwriting. We will divide out the 2 that's with it, giving us 27 for Jn. And so now it wants to know what is the length of Qn. Well, Qn is 1/3 of Jn, and again we'll put parentheses around it so we don't misread our handwriting. And if we plug in what we know, Qn is equal to 1/3 of 27, so Qn is equal to 9. And as we said before, Qn is equal to 9. If we do that whole thing and take the whole length, Jn, multiply it by 1/3, we get our answer. But if we take this segment length, because this is the 2/3 segment and this is the 1/3 segment, if we take our segment length and we just simply divide it by 2, we also get 9. So both routes are a way to come up with your answer. Now it says if J, L, and K are where these coordinates are given, what's the location of the centroid? So the centroid is located at my x values, so -3 plus -5 plus 1 over 3, and then my y values of 4 plus -2 plus 0 divided by 3. And -3 and -5 is -8, plus 1 is -7 over 3. 4 and -2 is 2, plus 0 leaves us with still 2 over 3, and that's our final answer. So the centroid, the central point of this triangle, is at -7/3 and 2/3. And so as always, pause this video, try to work these problems out before I go through them. But if we go for this first one, we want to find the length of AD. And so there's 2 routes that we could come up with doing it. We'll do it the longer route first. So AE, the length that I actually have, is 2/3 of AD, my overall length. So AE I know, so 21 is equal to 2/3 of AD. If I multiply through the whole thing with a 3, because that's going to cancel out the fraction, I get 63 is equal to 2 times AD. And then when I divide out a 2 from there, I get 31.5 being what AD is. And then again, the other way I could have gone about doing this is if I take 21 and divide it by 2, I would get 10.5. And then if I take 10.5 and multiply it by 3, I would also get 31.5. So both routes are valid routes for trying to come up with the answer. If we look at the second one, we're going to find AD as well. Well, we have the smallest length, the length that is 1/3 of the whole segment. So ED is equal to 1/3 times AD. And just like our last problem, if we multiply through the whole thing by a 3, 3 times ED is equal to 3 times a third cancels out, is equal to just AD. Well, I know what ED is, so 3 times 12 is equal to AD. So 36 is the length that I'm looking for. And for our last problem, we're going to find the centroid given the coordinates presented. So we have this triangle, ABC, should be a C there, ABC. So the centroid is located at my x values, 2 plus 10 plus negative 9 over 3, and my y values, negative 5 plus 52 plus negative 11 over 3. So 2 and 10 is 12 minus 9. It gives me 3 over 3. And then we have negative 5, negative 11, which is negative 16. And 52 plus negative 16 is 36 over 3. So my final answer here is 1 and 12.